In today's lesson, we're going to learn about a normal distribution. Our objective is to recognize uniform, skewed, and normal distributions, and to determine for a normal distribution the percent of data within a given interval, and to find percentiles. So first of all, if we have a set of data that is uniformly distributed, uniform means that there's a similar amount in each one. So a uniform distribution, if we did like a bar graph or histogram, would look something like this. Pretty uniform. Almost all of them have about the same. If it was skewed, skewed means it's just kind of pushed one way. So a skewed distribution might look like this. We have a lot of very low scores or low values, and then it looks like this. And then we have a normal distribution. This is the one we're going to talk about in great detail here in this lesson. A normal distribution would have most of them scoring kind of in the middle, and then it would go off uniformly, and it would be shaped something like the bell-shaped curve. So a normal distribution is talking about the heights of a normal 10th or 11th grader. So you could probably think of what the average height is going to be, and then you might have one very low or short person in your class, you might have one very tall person in your class. Okay, or on a normal bell-shaped curve, the majority of students would score on the test kind of the average or a C, and you'd have some that did excellent, like straight A's, and the same would have done on the other end. So it's a normal curve shaped like a bell. All right, so now the normal curve, what happens is it looks like this. And the middle score is the mean score. And we're going to symbolize that by X with a bar over it. Now, if we go one standard deviation, and we learned how to calculate that, above, so I'm going to add one standard deviation, and I'm going to subtract one standard deviation. About 68% of the distribution will be within one standard deviation of the mean. So in this range, about 68% of our data would be there. Now you can tell that this graph is symmetrical, so this would be 34% and 34%. Now if we go out a little further, it says about 95% is within two standard deviations. So if I go one more standard deviation above the mean on each side, then we've got 95% in this interval. Now you can see I've added about 27% and split evenly on each side. Would mean 13.5% would be in each of those areas. And then finally, we've got the three standard deviations within the mean, 99%, so almost all scores would be within three standard deviations of the mean. Now that's just another 4% you can see, which would be another 2% on each side here, leaving us about 0.5% on the very extremes, which would be considered our outliers in this case. Now, so anything that's normally shaped is going to use these percentages. So these are going to be memorized, and we're going to use these quite often. Okay, so now we're going to talk about a standard normal distribution. Now, if you remember, when we standardized values, We did this at the end of our last assignment, where you just took the score minus the mean and divided by the standard deviation. Our normal bell-shaped curve is going to look like this. Let's say there's a mean of, let's say 20, and a standard deviation of 2. That would mean that the mean score of 20 would be right in the middle of this. We could break it up by standard deviations, which is 2 in this case. And we would know those set percentages, like there'd be 68% in this interval, 34% on each side of 20. There'd be 95% within 2 standard deviations, that's another 13.5, another 13.5, and then 99% within 3 standard deviations, which is another 2%. Just a review of those percentages. Now, when we use the standard normal, we're going to always look at our mean as being 0, and then this would be 1 standard deviation above, and 2 and 3. This would be 1 below, 2 below, and 3 below. And these are referred to as the standardized values, or the z-scores. So basically we can take any set of normally distributed data and convert it using these standardized values and those memorized percentages.